to the recording service. Okay. Welcome everyone to the January meeting of the Stamping and Dies Tech Group as part of SME's Forming and Fabricating Community. And this is the 2015 meeting. My name is Eric Com. I'm going to be your host today, and I'm joined by the chairperson of the Stamping and Dies Tech Group, Brianne Roebuck. Hi, Brianne.
Hello, everyone. Nice to be
and we're also joined today. We're also joined today by members at large, Robert Strasser and Sam Welty. So welcome everyone to today's meeting.
Good afternoon.
Yes, good afternoon. I keep saying good evening because it's pitch black outside my window right now because it is 7 p.m.
Yeah, you got 7 o'clock over there now.
Yep, it is 7 o'clock right now, and it's pretty darn dark and cold and windy here in the northern parts of Germany. All right, so as far as administrative stuff, some things to discuss today. As I mentioned, Brianne is going to be serving as our chairperson this year. I will be helping her out as much as possible throughout the year, and I will be hopefully scaling up my participation in the metal forming simulation community. It is our goal this year to make it possible for us to have two technical side forming and fabricating community, one being the Stamping and Dies Tech Group, and the second one being a focus on metal forming simulation, which is my core business and core expertise. But in the meantime, we still, of course, will be running these meetings each and every month. What the plan is that we will continue having our meetings on the second Wednesday of every month, and I think in December, Brian mentioned we might be alternating schedules a little bit. And so what Brianne and I agreed upon, based on your guys' input, is that once a quarter, I'm going to hijack the Stamping and Dies Tech Group time slot to talk about metal forming simulation. And because metal forming simulation is still really in the house of discussions about stamping and dies, it makes sense for the meetings to be coinciding with each other. So beginning in February, we are going to run this meeting kind of a joint meeting between the Stamping and Dies Tech Group and the Metal Forming Simulation Group. And I will focus on materials information which is pertinent to metal forming simulation. And of course, those metal grades are what people ultimately stamp in their dies. So it should still hopefully be a relevant meeting for everyone. Just the idea is that we want to start expanding the activities in the other technical groups. In the meantime, we're going to follow a very similar editorial calendar to the way that we have in the past. So each month we will be following the schedule that I have illustrated on the slide on your screen right now, where in January we're just doing our once every 6 months discussion on stamping fundamentals. February we'll talk about material topics. In March, we are going to discuss press room topics, and I believe we've already organized a speaker. We have asked for some input from someone who is a press room maintenance and preventative maintenance specialist. In April, we will look to topics that broaden our scope outside of just stamping and dies, but something perhaps that delves more into the fabrication side or other modes of forming. And some of you should remember that that was the block that we had Rob Strasser talk back a few months ago, and he enlightened us a little bit more about stretch forming as a forming method. In May, we'll go back to design and engineering, which brings our focus back into design and engineering. And then in June, we have our mid-year review and our discussion on education and development. And then what happens is that after July, we just kind of repeat that same pattern, discuss fundamentals, materials, the press room topics, broadening to other forming and fabricating topics, discussion of metal forming simulation that will be coincident this year with FabTech, and also finishing off that 6 cycle with development and our year in review. So hopefully that schedule still sounds appealing to everyone as far as the rest of the year plan. And we will be hopefully once every few months discussing metal forming simulation in a bit more depth. And a couple times a year we will discuss in greater detail some aspects of forming and fabricating outside of conventional stamping and dies. I know that we have another person who joined us as I was going through the calendar for the year. It's Rich Glazier. Hi, Rich. How you doing?
Fine, thanks.
I don't know if you can. Okay. Thank you, Rich. We were just going through some brief announcements on the calendar for the 2015 schedule for the Stamping and Dies technical group meetings. Rich, have you joined our meetings before? I'm not sure if I remember seeing your name.
Yes, on occasion.
Okay.
Yes, I've seen his name here and there on the attendance list.
Okay, so my memory is just that bad. Okay, and we have another person. And we have another person who is signed in but doesn't have any audio yet. Hopefully they'll get that straightened out in a little bit. As normally when we kick off these meetings, we discuss the announcements for the upcoming meetings, and also another thing that's useful is talking about the other events as far as stamping is go, or the metal in 2015. So I can hear that we have our sixth caller on today. It's
Eric, you're fading just a
Greg.
little bit.
Is that Dopka? Okay.
That's correct.
Hey, Greg, can you hear us? Hi, Greg. You're joining our meeting today, and I don't recognize your name. Is this the first time you've joined a Stamping and Dies Tech Group meeting?
Yes.
Yes?
Yes.
Okay.
It's Jeff.
Okay. I'm getting a little bit of feedback off of everyone else's microphone. What I'm going to do at this time is I'm going to go ahead and mute everyone else's microphones except my own. And hopefully that'll keep me from cutting out all the time. I'm going to outline some of the events that I know of that are happening in 2015, and then once I do, I'll open the microphones back up and see if you guys have anything else to add to the calendar. Some of the global events for Stamping and Dies that are happening in 2015, Eurostampi in Parma, Italy. This is primarily the North American crowd that we have today, so I'm not sure if anybody is going to be joining the Eurostampi 2015. But another event happening in March, and this would be March 30th, my employers are hosting a free hands-on workshop on planning and bidding software and its application in planning and bidding sheet metal stamping dies. And that would be free for anybody who registers in advance for the event. So that would be March 30th, and that's going to be in Troy, Michigan. If anybody wanted to learn a little bit more about metal forming simulation software or digital methods for quoting tools, you could show up in Troy, Michigan on the March 30th, and you could register for our free planning and bidding seminar that I'm hosting in March. Other events happening in 2015 in Mexico, May 5th through the 7th. In Monterrey, Mexico is FabTech in Mexico. Also, May 4th and 5th at Northwestern University, which is in Evanston, Illinois, is the NADDRG. That's the website is the same. It's NADDRG.org, if memory serves me correct. And the North American Deep Draw Research Group is holding their it's no, semi-annual, right? So every 6 months or so, they host a meeting, and their meeting in the spring of 2015 will be in Evanston, Illinois. It's a 2-day-long seminar, and during that seminar, normally what happens is that the members of the Deep Draw Research Group will share any of their work in progress that they have developed on research and development in sheet metal forming. In May 13th, in Livonia, Michigan, there's the Great Designs in Steel, which is sponsored by the Auto Steel Partnership. So that would be www.autosteel.org. And this every year is usually a really fantastic seminar, expo, and exhibit on what's going on as far as high-strength steel and high-strength steel applications, predominantly for the automotive industry. In June, there's the International Deep Draw Research Group, which will be hosting their annual meeting in Shanghai, China. I don't know about you, but I unfortunately would not be able to attend that meeting. Nobody at my company is going to be sending me to Shanghai, I think. And then, of course, in November, we will have FabTech 2015 in Chicago, Illinois. So that's the big FabTech show every year, and be November 12th. This time I'm going to go ahead and unmute everyone else's mics, and if you guys have something to add to that calendar, please go ahead and speak up and let me know. Like Natalie Lowell, who just joined us from SME staff, might be able to tell me of something I forgot.
Hey, good afternoon. How you
Hi,
guys?
Natalie.
Hi. I don't have anything to add at the moment. I will look while I'm on mute to see if there's anything more I can contribute on your agenda.
Okay. There's most likely going to be an SM. Go ahead.
Oh, I was just about to say, with FabTech America, then FabTech Mexico, you also have FabTech Canada, which I just looked up is March 22nd through 24th, and that is in Toronto.
On March 22nd through 24th of 2016.
Oh, that is true. Sorry.
I know. I did the same. I did the same thing today as well. Yeah, I was looking at the calendar and I thought for sure there was a FabTech Canada coming up, but it's not coming up until the 2016 calendar year.
Okay, and then the second thing I have is the SurveyMonkey thing that I think it's, Natalie can tell us more about it, but it's the center of a focus group sessions that they're being held through the first quarter of 2015. And they would like people's input that are within the manufacturing industry, and we would like to get some stamping people in to share their opinions too. So
yes,
I just put a link in the chat box.
That is what I think Eric should have up on the screen right now, correct? The EWI open survey?
Correct.
Okay.
Yeah. And that's one thing that maybe Natalie, I'm going to go ahead and mute everyone's mics and then unmute you, Natalie, and then maybe you could share a little bit more about this SME, PMA, EWI, NST project.
Okay. Can you hear me okay? Hello?
Yep.
Oh, okay, great. Yes, so thanks, Eric, for that. I know Eric and Dean Phillips and Charles Karastan from our community, they joined us for a face-to-face meeting at FabTech in November of last year. The focus group meeting has actually been hosted under the EWI, which is Edison Welding Institute. They have taken on a grant from the Advanced Manufacturing Technology Office under the NIST umbrella, and they are actually creating a roadmap for forming and joining technologies. And in the roadmap development, we have been as an SME representative for forming and fabricating. I've been on a steering committee with partners from PMA, and American Welding Society, and other organizations and we are actually dividing and conquering what the roadmap would look like under those two very specific subjects of joining and forming. And the outcome of this activity at the end of the year is to produce a roadmap of where technology is going related to those, the development of those technologies related to joining and forming. Inside that roadmap, we are covering the technologies, the equipment, the breakthroughs. How do you take those breakthroughs in research and apply that so that users, manufacturers in the industry can actually take the technologies and apply them to actually make things with these new technologies. So that's one avenue. The other is the workforce. We're addressing workforce and what kind of workforce is needed by industry to support these technologies in the future. And so those are kind of a couple of the big elements there. The focus group survey that Brianne mentioned is an open survey that they'll have up for another, I think at the end of April, or not end of April, excuse me, end of March. We're gathering data from the industry to help us populate the roadmap. That's one piece that they're doing is the survey. Then we've also gathered a lot of industry white papers and knowledge and research, and that's being vetted right now with the EWI, who is the point group for this roadmap development. So we meet on a monthly basis as a steering team and contribute. We are projecting to have an activity at FabTech this year to hopefully roll out a draft plan of what the roadmap actually looks like and get feedback from the FabTech audience on this roadmap. At the end of the year or going into early 2016, this roadmap, once it gets finalized by the industry with EWI as the lead group, it will be presented to the NIST AmTech office as the recommendations for how to pursue and go forward with the industry in joining and forming technologies. The idea in the roadmap would be recommendations of where we are requesting funds be spent in the future to grow the technology areas or to grow the workforce based on the recommendations that are in the roadmap. Beyond that, there's a sustainability document that EWI is putting together that says, how do we continue to work as a consortium like the steering committee to keep the roadmap and the work going beyond the close of the contract, which is 16. I know that was a lot of information, so we can take questions, or I have information on the website, and Eric, maybe what I can do is direct you to the link, and then you can share that with everyone that has some of
that would be great.
Okay. And Eric, you were at the meeting at FabTech in the fall. Maybe you can share with some of your members any points that you may have taken away. Do you have anything?
Well, the big takeaway for me was that the big takeaway for me was that the big takeaway was that the things that we've been talking about, the need for technology implementation, the need for workforce development is being recognized and being heard, and that SME, PMA, along with the help of EWI and through the NIST, it seems like at least somebody in the government was listening to us enough to fund this project, and that if we collect our thoughts this year, they will be heard at least, and it's a great opportunity for us to find out and to unify in what we want to say and make sure that we're heard. And that's, for me, the biggest takeaway was that we're not alone shouting in the woods.
Well said.
Thank you for that update, Natalie. Okay. So for sure, if anybody wants to take increased participation in that, when we distribute the meeting notes and minutes, I'll be sure to have that link from Natalie as to where we can find out online what activities were planned for 2015 regarding this initiative, and then if you have ways that you would like to participate, or you just want to find out how you can participate, continue coming to these monthly meetings, and anything that we learn about it, we'll be sure to share with you guys. Okay, thank you. The topic that I had floated out there today as a possible topic for the technical discussion today. I just called it stamping fundamentals, and I wanted to talk about the stamping press line. But I didn't necessarily think that there was a lot of new knowledge or new information I was going to bring regarding the stamping press line. What I wanted to do is I wanted to share a discussion, open a discussion with you guys on the stamping press line, come to a common understanding of some terminology, but use this discussion on the stamping press line to identify and to recognize what are some technologies or what is some information that all of us might benefit from if we were to expand or drill down a little bit deeper in regards to the stamping press line. So what's illustrated on the screen at this moment is a little illustration I found online of a possible stamping press line, and I just wanted to share with you some insight, and then start asking you guys questions for what are some technical topics and what are some technical concerns that we might have regarding the implementation of these production press lines. So in this illustration, I started off very simple with at the front of the press line, I have a way of handling the incoming material, and typically the incoming material, when we think about it, is either in the form of sheet metal coil, or perhaps it would be material coming as pre-cut or pre-sized blanks. And that would be our feed of the material. And then when we think about the press line, another aspect of the press line is the press system itself, which is possibly a series of individual presses that are just lined up adjacent to one another. But some of you might also hear terminology around in your field, or maybe heard us talking about it during these meetings, discussions of transfer presses, or maybe you hear about progressive presses, right? So when we think about a press line, really the press line is some way of feeding material into either a single press or a system of presses where we are going to do some metal forming or some material deformation. And when we think about that front of the line system, that front of the line system that I mentioned, two different varieties. Here I have a coil-fed system where the material is uncoiled off of the mandrel of the coil feed, is brought through a machine that is most likely straightening that material, as well as possibly cleaning that coil. The material you see drooping down into a slack pit and then back up into a feeder. And this is the coil feed system. Right now, sometimes that coil feed system might feed directly into the manufacturing production line. Another possibility is that people will have just a press here that is just blanking the material, maybe cutting it into nice little trapezoids that are showing on the bottom illustration here. And maybe those trapezoids are stacked onto pallets, and then pallets full of blanks are shipped to a manufacturing facility, and then those individual blanks are fed into the production. Interesting is I would open up the discussion about production lines by just thinking, what are some of the topics when we think of that front of line of the manufacturing facility, and what are some of the mechanics that we are concerned with, and what are some other manufacturing issues that build into how that affects our own manufacturing processes. So at this time, I'm going to go ahead and unmute our microphones. Can somebody tell me, when it comes to that front of the line, that coil feeding or blank feeding operation, what are some of the other technical concerns that we might have that affect our manufacturing ability, throughput, our quality, or our costs?
One of them could be joining coils, like when you switch onto a new coil. There's always concerns with keeping production time and reducing downtime.
All right, so coil changes, right? If this is supposed to be a constant manufacturing operation, you run through one coil of material and you want to change over to another coil of material. That certainly is another one of those technical concerns. Good one. What other concerns do we have, whether mechanical or throughput production or other interesting aspects of this front of line coil feeding or blank feeding operation? Okay. Greg's typing rather than speaking. Everyone's mic is open, but let's see. Greg mentioned material camber, right? That's the tendency that this coiled material might not end up being perfectly flat going in. He mentions oil canning and variation in the material hardness, right? There's quite a bit of discussion when we talk to these people who supply these straightening feeds and these feed mechanisms. There's a lot of discussion about how does that material's characteristics vary, and can we use those coil straighteners and the coil feeders to try to bring that back into some reasonable area of control, right? And so those are great points. Thank you, Greg.
Let's see, another one that connects in is different types of accumulators, because you had a slack pit, which a lot of the processes that I see, some of them have a little pit, but there's also definitely other types of accumulators, like accumulator silos, stuff that go the whole length of the building, like in the ceiling area. And then also an interesting thing called fluke rolls, which our company has dealt with replacement parts for fluke rolls before. So those are all types of accumulators, the coil feeders.
Right, and that's a good point, right? I think in that last illustration, I had a illustration of a slack loop pit, right? And I know a lot of people have asked me, what's the purpose of that loop pit? And that's really to deal with the fact that if we're uncoiling a coil of material, this looks like a relatively small coil of material, so maybe that coil of material is only 5 or 10 tons. But maybe some large coils of material that I've had to deal with in my major body stamping are anywhere from 20 to 60 tons of coiled material. And once you start unrolling that coil of material on that feed mandrel, we really prefer to keep that unrolling at a constant rate. But in the meantime, we have a press that's indexing the material incrementally. And so we use this slack loop pit to allow us to continuously put material constant rate off of the feed roller, and we accumulate a little bit of slack inside that pit, and that way the incremental feeder pulls in exactly how much material it needs for that one stroke, right? But in the meantime, that's not the only methodology, right? There are ways that people are installing a loop pit. I know that when you go to Fab Tech every year, you'll see people selling different types of accumulation devices, maybe that are making the material go up into like a silo and then down into the incremental feed, and even some compact, the most compact accumulation devices are really just creating a slack of material around the mandrel itself. and then feeding directly into that incremental feeder, and just using the slack of the slightly loosened or unwrapped material around the coil in order to feed into that coil feeder. Right, so that's a great point to bring up, right? Festooning. That's a great word, Greg. Thank you. What other things do we have a concern with that incoming material? All right, so we've mentioned a lot of things about the coil feed. I had already made notes on my slides earlier. D-stackers and fanner magnets. Quite often, when you, if you were to receive a stack full of sheet steel, they'll quite often use fanner magnets, which are just magnets that are put on the side of a stack of blanks, and that way, when we pick up one blank, the magnet are holding the other blanks down in place and fanning or separating the individual blanks of material so that the hydrostatic pressure of the lubrication is not causing us to pick up more than one blank at a time. The reason why I made that note just this week was that it turns out that some of you might have noticed that Ford just won Truck of the Year for the 2015 F-150, which is going to have aluminum body panels. And that was a problem when you stamp aluminum and you start stamping a lot of sheet aluminum, that these fanner magnets no longer help you destack or unstack the material. And now they start having to find alternative methods to separate the individual blanks from one another. Another problem that we always had with aluminum panels when we stamped them was that they were so light that we quite often did pick up 2 or 3 blanks at a time with the suction cups, and that the hydrostatic pressure of the lubrication really caused those blanks to cling together, and we always had to try to figure out creative and inventive ways of separating individual blanks, support these blank methodologies. And, of course, one of the things that we will end up talking about more in February as we shift topics toward material properties and the metal forming simulation, we will talk about the blank properties, right? How repeatable are the material properties? And material grades, right? Are the materials grades or specifications in spec, right? That's always a problem, always a concern for people when we talk about the coil feed and the blank feed, is that, yeah, once we unroll the material or we load it in, how do we know that that's the material that we in fact ordered? Some other things we can talk about in regards to press systems are different press types. I uploaded a couple of videos. We'll see if those videos will play for us today. The first video I'm going to show you here on the left is a tandem press. And when you hear people talk about tandem presses, what are we really talking about? We're talking about a system of individual presses. So these presses were, in fact, separate machines that we've just connected together with electronic controls so that they operated as a system. And you can see that in this tandem press system I'm illustrating on the left, I'm using a robot to move material from the initial forming operation, perhaps on the left-hand side of your screen, and loading that material into what might be a trimming or a flanging operation in the right-hand side of the screen. So when we talk about tandem presses, they're individual machines, each holding individual dies, and those individual machines and dies are completing separate stages of the forming operation. So if we have 3 or 4 operations to form a part, it might be subsequently drawing, trimming, piercing, and flanging that part to form that body side panel. So what you can see in this illustration again, we're taking a formed part out of one die, and it's a robot, in this case, picking up the part and shifting it to the next press. And those presses are just trained due to their electronic controls to behave as a single system. but they are still individual presses. Now, it's a little bit different than when people talk about this idea of transfer press. A transfer press is, instead of individual presses, it's a large press that now holds a system of dies. In this video, what I'm doing is I'm showing a flat blank being loaded using press-mounted automation that we call a tri-axis transfer. And that tri-axis transfer system is moving the part into those system of dies, into that series of dies that are all contained inside of the same stamping press. So the difference between the video that I'm showing right now on the right-hand side of the screen and the video I previously showed on the left is that those tools, when you see those tools going down and up, that's really all being accomplished by a single mechanical device, a very large press. And this one large press is using a large drive mechanism to move those rams or those slides, and those rams and slides are holding a system of dies. So in this case, I have 4 individual dies, and those 4 individual dies are attached to different rams inside that press, but they're really moving all as a single system. And that with a transfer press, unlike the tandem press I showed on the left, rather than having individual robots in between the individual presses, we instead are using a system of automation that is built in and synchronized to the press action so that we can very elegantly, very easily between the press opening and closing again. And that would be a transfer press. Now, when we think about the press system, there's really just those 2 types of presses. They're either individual presses that hold one tool, or they're a special press that can hold an entire series of forming operations. We can talk about in regards to these press systems. So besides just knowing that the presses are operating individually, they are possibly operating in a system. Some people might also be concerned about the press's drive mechanism or press monitoring or press automation. So again, as a thought starter, I started this table out writing down some different things about press systems, the different drive mechanisms, hydraulic, mechanical, and servo, and different things that can be monitored on a press. I just listed a couple. The press tonnage is, of course, a monitoring issue, and press safety, of course, is an electronics or monitoring issue. And we can also talk about, the same way I showed in the video, we might be relying on robots or a transfer mechanism. What are some other areas of technical innovation or technical sharing that we can discuss regarding those individual press systems? I've unmuted all of your microphones, so you guys can please share with me your thoughts on press systems.
Now, stamping is out of my field, but on the monitoring, aren't there systems available for in-press checking, for wear and breakage on detailed components within the die set?
Yeah, actually, that's a great point, right? In addition to just monitoring things like tonnage or press energy and things like that, there is in-press and in-die checking of things like part quality, right? There's also sensors that we are using to know, is the part present? Right? Part present, part not present. We have in-die monitoring that people sometimes use to see, did a hole get pierced or not? Is the part having the correct shape? Is the part having the right geometry? And I've even heard people talk about some innovative uses that they project in the future we might be doing is using those in-tool monitoring systems that if they see something's out of spec, actually use information to drive a different behavior into the tool. Things like automated wedges that could be used to change the way the tool is configured or shaped to form a part of a better quality.
Right. And how about on the automation?
What other are of note? Sorry, Bob, I cut you off. You were saying?
Yeah, I was going to say on the automation side, you know, I think I've seen some articles where they talk about doing in-die tapping, or you know, some kind of thread creation, and the components as they're being as they're going through the process.
Yeah, we have automation in regards to like in-die systems. We have, of course, in-die assembly.
True.
Right, and those types of things like the clinch die assembly. I believe I even saw once the transfer press. It was a transfer and a progressive press running side by side that would take the individual parts that were being stamped and then shuttle them together and fasten them inside the press to one another. Let's see, servo, yep. Greg mentioned again that servo is a huge trend today in regards to the programming that can be done with them, right? Because you get different stroke rates as well as stroke lengths, pressure application, and those things are all things that when people are choosing whether it's a hydraulic drive system, mechanical drive system, or a servo drive, it's quite often because they're concerned with things like force application or stroke lengths or stroke rates or things that you can do with hydraulic and servos like dwelling at the bottom of the stroke.
Yes, and along with the drive, I guess the general term would be retrofitting the current drive that you have, especially lower budget manners. I know my dad is pretty interested in servo cushions themselves because he doesn't have the money to put into a brand new servo press, but the cushion can then can provide some of the benefits that would come with a servo press. And I can also say with some mechanical presses, you have to put in a hydraulic process to like get the part to come off, to strip off the die, using really complicated geometry. So there are times where you're adding other things to your primary press drive.
That's a very good thing, right? You mentioned the press cushions, right? And there is this new servo valve controlled cushions to the very traditional pneumatic cushions that we've had in the past. Some presses have hydraulic systems. Some presses have hydraulic and pneumatic systems, you know, air over oil systems. I misspelt borne there, but press-borne pressure systems that might be used for forming or for part stripping. And Greg mentioned that one of the things that people like the servo presses for is that servos are a bit more robust when it comes to this idea of snap-through or breakthrough tonnage in a way that hydraulic presses and mechanical presses are a little bit less friendly. There was something else you mentioned right at the end there, though, Brianne, or did I get it?
I don't know. You're going to have to click off of that typed box to see what you're writing. Okay, press one cushion. I think a lot of that is within there. Yeah, and then
Okay.
yeah.
Right, so the press systems are more complex. You mentioned the whole idea of the retrofitting of the presses. Of course, the press systems themselves, very complex hydromechanical systems, right? One of the things that when you think about the hydromechanical and electrical systems that make up our stamping presses today, it's a very technologically computer savvy field working in a press shop, because you end up having to employ electricians, computer programmers, people who are doing PLC logic, as well as mechanical engineers who are familiar with pneumatics and hydraulics. It's really quite a robust, quite a complicated manufacturing system being in the press room. Okay, thank you. And then, of course, the side of the press, the only reason we buy the presses is because of the dies that we want to operate inside those presses. So when you think about the dies that are inside the presses, in the top of this illustration that I have on the left-hand side of the screen, this is a very simplistic cartoon of a transfer press. And in that transfer press, I have 3 individual dies, a draw die, a trim die, and a flange die, and those individual dies are all being operated by a single press, as I mentioned, a transfer press. Or I could take those 3 individual dies and I could insert those 3 individual dies into a series of freestanding presses. So in this case, the bottom illustration is that idea of a tandem press. And each one of those presses inside the tandem press line is holding an individual die operation. And those dies are individual tools, they're individual purchased products that we're getting from a manufacturer who's custom making those dies for us. Now, that's a little bit different than what you might think of when people talk about progressive die operations. And somebody, when I was showing the transfer press and the tandem press line earlier, they might have thought to themselves, hey, Eric, you didn't mention progressive presses. Well, progressive presses are kind of a misnomer, because a progressive press is really no different than any one of the individual presses that I've discussed today, or maybe a transfer press, right? It's just a mechanical or hydraulic or servo-driven press with a frame, and inside that frame, the press drive is making a ram go down and up with portions of a die on it. The difference with a progressive die operation is that when you think about a progressive die, instead of having individual tools that complete the forming operation, we instead buy one big complicated tool, and that big tool is going to perform some individual cutting operations, possibly a sequence of sequential forming operations or progressive forming operations, perform some more cutting, some more slitting of the part, and finally at the end of the tool, the coil comes out of the other end, and there's a fully formed part attached to that coil, and we separate part from in the left. And the real difference between the operation and the tations or transfer operations is that when you think about progressive dies, the automation that moves the part through the individual forming sequences is the coil of material itself. And so a progressive die operation is the automation that you have is usually just a coil feeder, and in many cases a coil puller that is pulling the coil through the press line and indexing that coil so that every distance that coil travels, or what we'll call a pitch, for every pitch of metal coil, share that, and those are what we talk about when we talk about progressive dies. So when we talk about dies, of course, there are numerous concerns when we think about the various tool types, whether they're individual tools or progressive tools, and many topics of concern regarding tooling engineering, the material made of, and their individual die components. So I'm going to go ahead and unmute everyone's microphones again, and please share with me some of your observations or your concerns when it comes to dies and die technology. We're all quiet today.
I think we lack a springboard because this is like the whole tool and die maker field. Well, the dies,
it's everything. There's so many things to talk about.
Die changeover would be one of the things when you're actually trying to set it up the first time in a press. I don't know where that goes under.
Yeah, I'm just writing it down randomly wherever it fits, right? So we can talk about die changeover, which is, you know, from one production run to the other. But there's also the die tryout, right? We move a new product. It's a whole new product. We can talk about die validation of a new forming process. Greg mentioned this idea of the SMED, which is that single-minute exchange of dies, or QDC, which is the quick die change that we discussed as a topic last year. Oh, I saw this. Someone gave me a huge list of topics. For design and engineering, material topics, tooling and sheet metal. There's different forming types when we talk about drawing, trimming, piercing, and flanging. But of course, there are other forming methods like hydroforming, which I'm not discussing when I talk about die-based forming, because hydroforming can be done using bladders as opposed to mating male and female dies. What are some other concerns regarding how dies operate inside of the presses that might hopefully fuel our what we know information you guys need so that we can go and find guest speakers to talk about these topics?
Yeah, one of the things that we've seen on there are a couple of parts that we make that we actually work with the stamping house to create blank form. But stripper type and stripper pressure determination, that's a big for us.
Right, so when you think about tooling engineering, stripper types, stripper pressures, or
for general methods.
I don't really have
and of course, right, and tooling forces. You know, how much force does it take to form this part?
Yep.
But Jim has being a full die maker responsibility because of the wiring machine. So rather than me asking specifically, when in theory we might go to you know everything having to do with the wiring machine. Yeah. Could you maybe get some thoughts on some of the Jim Paxton specific stuff, which I believe is just the wiring machine and the hood code. Yeah.
Okay, it sounded like Greg was having another conversation offline.
Yeah, for a second there,
but
I
Greg
was like, do we need to find a wire EDM speaker?
Yeah, but no, it sounded like he was mentioning cut edge. But yeah, that does bring up a good point, right? Tooling, manufacturing, right? Wire EDM versus CNC machine. Right, and that's another thing that was always an interesting topic when we talk about what are the technologies that affect forming and fabricating. And Dean and I always talk about this, that forming and fabricating, just about every one of the individual verticals inside of SME in one way or another affects the sheet metal stamping, sheet metal forming and fabricating, right? That there is no stamping without material removal and machining, because the MMR is just part of how we create the tools. So if it's EDM or NC machining, we're seeing that 3D printing is starting to affect sheet metal stamping. Our people print or manufacture tools themselves. Some of the other avenues of course, the automation. There's the automation interests inside of SME, and automation is a huge part of moving those parts through the stamping operation. And it is quite possible that stamping and forming and fabricating is one of the most broad areas that you could look at when it comes to manufacturing and manufacturing engineering. What other concerns or what other things come to mind when we think about dies and die technology?
Two that came to mind was maintenance work within tooling, and then also just the physical cam technology of when you have to, especially like if a die comes down but you need the force to come sideways or at an angle, it's not a straight up and down motion. Cams are one of the ways to change the direction of the force.
Cams are always a very sensitive topic when we talk about tooling engineering and tool design in stamping and process design, because we're constantly trying to convince our product engineers to make everything line up either perfectly horizontal or perfectly vertical, because if it's not perfectly horizontal or perfectly vertical, then we have to come up with some sort of mechanism that translates linear force along a different vector, and that means we have to add cams to our tool, and that adds cost and complexity. There are a fair number, and many of these things and many of these topics that we are typed into the chat box, that there are many of these things we mentioned on the forming and joining roadmap as technological gaps, technological things that could be improved. Maintenance, there's the mechanical repair, mechanical maintenance of the presses, predictive maintenance. That is, I think, one of the topics that we are going to try to tackle this year, is get somebody in to be a guest speaker and talk to us about predictive maintenance of these complex mechanical systems that are our stamping plants. Good feedback, everyone. Great. So what any other input, any other comments or technological concerns you guys can think of? Die life, and die life and coatings, substrates. What are the tools made of? How long do they last? Of course, we get die life. And, of course, lube always becomes a sensitive topic when we think about that as well. Great feedback, everyone. That's kind of the end of what I was going to walk us through. I want to mention one of the things that we wanted to achieve. We fell short of our goal last year, and this year I want to re-energize everyone to think about this. But I would really like to, if this year we could achieve something as a group, and I know that we were talking about this EWI road mapping project. One of the other things at this discussion today of the stamping press line reminded me that Brianne and her dad have donated to our group this press. That's Brianne in the picture on the left, and what Brianne's standing in front of is a small benchtop press that her father and she are in the middle of doing some refurbishment to. They've taken the press apart, they've done some repairs on it, and I believe Brianne's dad was talking about hooking up a small motor to that press so that we could have our own operational mechanical press. Brianne also was doing some project work last year and was trying to come up with a controls mechanism using a small programmable controller called an Arduino in order to come up with a way to control the press feed. And one of the things that we had talked about was using this press as a technology test bed, but also a technology proof of concept. Any group look at its controls and press improvements.
You might have to attempt to say that one more time because you broke up a lot during that particular statement.
Yeah. Yeah, somebody was standing outside my door stacking cups and glasses. The idea was, one thing that we want to achieve is create a working model press line using that press that Brianne did. And we've been talking about shipping that press to the various SME or PMA events that we participate in, and using that press as an opportunity to educate our members and also increase interest in this, as we discussed, very broad technical field of sheet metal stamping, and let people know that when they're talking stamping sheet metal, there's a lot of technology and innovation in press feed and press controls. There's a lot of technology and innovation in press drives, controls, and safety, as well as technology and computers required to do tooling and tool design, and of course, automation. So one of the things we wanted to achieve with this technology group in the coming year, or coming years, is make that press created form. And so one of the goals that we have this year, I'm trying to see if we can't get somebody to donate a small die set that could operate in this small benchtop press. I was willing to to donate some engineering time to engineer a tool configuration so that maybe we could take thin stock aluminum roof cladding and stamp something inside of this small benchtop press, and everywhere we go we could show people what we're talking about when we talk about sheet metal stamping and sheet metal dies. The other thing that's a goal that I have this year for the Stamping and Dies Tech Group in conjunction with the Metal Forming Simulation Tech Group is there's really no well-defined standard in the industry for how one should perform a metal forming simulation. So I was hoping to drive our conversations and drive the technical group into documenting some best practices when it comes to performing metal forming simulation. I'm hoping that we encourage all of us to curate and host a materials properties library, or expand the SME wiki so that it could contain up-to-date information regarding material properties and material types and material grades. And one of the things I was hoping to achieve is to host a materials information exchange so that SME members who are participating in the metal forming simulation activity could find their peers in the industry who might already have information about the materials that they're forming. And what other things could we do as a technical group that would make this group valuable for you? Just those ideas. Well, think about that this week, okay? One of the things that I'd really like to do is hear from all of you in the after these meetings, and hopefully something that we talked about, materials exchange, could it happen in person? What do you mean by that, Natalie?
Is that a virtual event, or is that something that you do online? or is it something that you can do at an event?
Thinking the materials exchange would. Yeah, by materials exchange, what I meant was materials data or information exchange. So that would be a virtual event or a virtual marketplace where if somebody said, I need a material model for this DP 560 material, I might be able to share with them some information I had about that material.
Okay.
A Craigslist of data?
Exactly. Exactly. That people would, because quite often many of my customers are testing materials that they are running in their production environment so that they can get good material models. And in the meantime, that means that they have to spend extra money to run the test every single time. But possibly some of their colleagues and peers could benefit from the material tests that they've done, and they could share information as well. And everybody just is, we're all better engineers when we have more information.
So is there a group or a site out there right now that's doing that?
No, there is not. This is something that we could be 100% greenfield on, Natalie. Okay, well, that pretty much brings me to the end of my agenda, and I promised one of my colleagues that I would meet him for dinner at 8 o'clock, so I'm a little bit late. I don't know if there's anything else anybody else would like to add, but please, I'm going to type my email address up on the top of the screen.
Dinner at 8 o'clock.
Consultant.
It's 2 o'clock in Dearborn, Michigan.
I'm in the central. Yeah, it's 8 o'clock here in Europe. It's 8:06 right now in Germany.
We've truly had a virtual.
So on the screen right there. Thank you, everyone. I appreciate all your input. The meeting was recorded again today, so anything that we'll be able to share this meeting recording once we get the video or recording back online. And please